After the aviation disaster that claimed hundreds of lives, the Indian government immediately launched a nationwide large-scale investigation. Amid the still smoldering wreckage from the recovered black boxes and radar data capturing the final moments, a shocking truth gradually emerged. The tragedy designated AI-171 may not have been an accident, but the result of a deliberate plan. Some experts even warned both engines ceased functioning almost simultaneously, something nearly impossible for a Boeing 787 equipped with such modern technology. And the final takeaway may lead the entire world to view Boeing through a completely different lens. When the last body was removed from the scene, only one question echoed through every press conference: what truly killed AI-171? Immediately after the fateful collision, emergency investigation teams entered a life-or-death race to trace the root of the tragedy. In less than 28 hours, both black boxes, the cockpit voice recorder CVR and the flight data recorder FDR, were found in the ruins of the dormitory building. Technicians began recovering data from the scorched devices amid hundreds of tons of debris, marking the beginning of a detailed analytical sequence. From the data gathered, the team of experts immediately began analyzing a series of key factors: cockpit audio recordings, engine thrust levels, flap configurations, landing gear positions, and control inputs in the final seconds before the crash. At the same time, another group focused on meticulously inspecting each recovered wreckage piece. They paid close attention to fuel filters, pipelines, control valves, and the remaining fuel in the tank, to determine whether any signs of contamination existed. As the investigation entered a deeper phase, attention began to focus on two main areas: the electronic engine control system and the composite material forming the body of the Boeing Dreamliner. A bitter irony: the very components once seen as technological breakthroughs might have become the weak links that triggered the disaster. Flight simulations on supercomputers revealed abnormal engine behavior. At the same time, laboratory tests detected microcracks in some composite material samples, a sign suggesting that the aircraft's structure may have fractured under sudden acceleration pressure. However, the most critical clue emerged from a desperate distress call. In the cockpit voice recording through the static noise of the radio, a terrifying scream rang out: "Mayday, mayday, no power!" That was the moment the crew realized both engines had lost all thrust. The absence of the signature roar from the GNX engines, which should have accelerated at that phase, led the engineers to a preliminary conclusion. The aircraft had suffered a sudden power loss, not a gradual engine shutdown. Such a scenario could only occur under two rare conditions: either both engines simultaneously ran out of fuel, or a failure in the electronic control system abruptly cut off the signals. Based on initial findings, investigators proposed four main hypotheses. First, a foreign object might have struck the aircraft, damaging the engines. Second, the flaps may have been deployed at the wrong time or in the wrong sequence. Third, a cockpit error caused by the pilot's own actions. And fourth, now under intense scrutiny, was there a mistake during the maintenance conducted 3 months prior? Mr. N. Chandrasekaran, chairman of Air India, believed that the tragedy might have resulted from an unfortunate combination of engine thrust failure, incorrect flap configuration, or a delay in retracting the landing gear, factors sufficient to destabilize the aircraft during the most critical moment, 30 seconds after leaving the ground. And that was precisely what made the incident extremely unusual, according to the captain and former senior investigator of India's Aircraft Accident Investigation Bureau, who said he had never witnessed a case where a routine takeoff ended in a crash just 30 seconds later. But AI-171 was no ordinary flight. It was the symbol of Air India's rebirth under Tata Group, launched less than a year after the airline was privatized. The Boeing 787-8 Dreamliner had completed more than 5,000 hours of long-haul flying. Its design featured advanced composite materials to reduce weight, improve fuel efficiency, and enhance passenger comfort. from panoramic windows to a lower cabin altitude. Professor John McDermott from the University of York, UK, an international expert on aviation safety, also emphasized, if a crash occurs below 200 meters, there is almost no chance of recovery. The pilot can still abort the takeoff until the very last second. This shows that the disaster happened either too abruptly or right as the aircraft lifted off the ground. According to scientists, another possible cause of the tragedy is that birds struck the aircraft and simultaneously damaged both engines. The city of Ahmedabad is located near residential areas, which causes its airport to frequently report bird strikes involving aircraft. Statistics from 2023 show that Ahmedabad ranked second in all of India for the number of bird strike incidents. Dr. Jason Knight, an expert in aviation biology, stated that if this scenario is accurate, both engines likely failed after birds were ingested into the combustion chambers. This is an extremely rare occurrence, but not unprecedented in aviation history. Another analyst pointed to a possible fault in the flap system, a critical component responsible for generating lift during takeoff. If the flaps were incorrectly set or failed to operate properly, the aircraft would not be able to produce sufficient lift to safely leave the ground. In hot weather conditions and with a heavy load, a flap malfunction could lead to a lift loss phenomenon, causing the plane to crash right after lifting off. So did the root cause come from the cockpit crew. According to Reuters, both pilots were highly experienced. First Officer Clive Kundar, who sent the distress signal, had logged over 1,000 flight hours, while Captain Sumit Sabharwal was a seasoned flight instructor. However, radar data revealed an abnormal detail: the flight crew did not use the full length of the runway. Instead of utilizing the entire runway, the aircraft accelerated over a distance of less than 2,000 meters. At that time, the temperature in Ahmedabad had risen to 40 degrees Celsius, causing the air to become thinner and reducing lift efficiency. Under such conditions, the aircraft was required to reach a higher speed than usual in order to safely lift off. If the plane failed to reach the necessary speed or lift, it could easily collide with low-level obstacles after leaving the runway. Aviation experts stated that for a nearly fully loaded Boeing 787 carrying enough fuel for a 9-hour journey, the minimum runway length required for a safe takeoff was approximately 2,500 meters. In extreme weather and with maximum weight, the decision to shorten the runway turned every minor malfunction into an irreversible disaster. While the pain from the AI-171 tragedy had not yet faded, a wave of suspicion began to rise, not from outside conspirators, but from within the aviation industry itself. Why has Boeing remained silent? For what reason has the world's largest aircraft manufacturer not issued any official explanation following the crash of Air India's most advanced plane? According to a leaked internal document, never publicly released by the media, a group of engineers in the Dreamliner test program had repeatedly warned about sudden signal loss from the Engine Electronic Controller (EEC) during emergency simulation drills. This is the central system that controls engine thrust, the electronic heart of the aircraft. Yet instead of being seriously addressed, the report was stamped "not severe enough to suspend operations" and was quickly dismissed from the risk assessment process. And that was not the only report. Another leaked email from Charleston, the main assembly site for the 787 line, revealed that since 2024, wiring near the EEC cluster had caused temporary electrical short circuits during ground tests. Some reports even recorded abnormal EEC fail warnings during system startup. But none of these logs were ever reported to the U.S. Federal Aviation Administration, FAA. Now, a chilling question is being raised. Did Boeing know about the potential risk from the EEC system, but deliberately ignore it due to the enormous cost of correction? If this is true, then this is no longer a technical fault, but a systemic failure, legitimized by silence. In that case, Boeing would not merely be a victim, but the silent architect behind one of the most haunting disasters in modern aviation history. One detail that shocked many aviation experts was the right engine of AI-171 had been replaced only 3 months before the accident. Initially, this seemed like a routine technical fact until several anonymous sources within the aircraft maintenance industry spoke out. According to a former technical supervisor who worked for a subcontractor of Rolls-Royce, the engine supplier for the 787 series, there had been cases where engines recovered from decommissioned aircraft were reintroduced into the supply chain under the label of certified standard. We've seen engines reused after just a few surface-level repairs, even though internal signs of oxidation or microfractures were already present, the individual shared. The alarming issue is that the replacement engine installed on AI-171 might have been one of those. If this turns out to be true, it would represent a serious breach in the quality assurance and safety oversight system for the entire Dreamliner fleet. Even worse, the use of recycled or substandard components is often driven by a single motive: cost-cutting. As Air India rapidly expands its fleet following its acquisition by the Tata Group, the push to bring more aircraft into service may have exerted intense pressure on the parts supply chain, especially for high-cost components like jet engines. While investigators were still struggling with dozens of unresolved technical issues, another voice unexpectedly rose from India's political arena. A senior member of the Shiv Sena UBT party publicly called on the government to launch a full investigation into the possibility of sabotage involving Air India's Boeing 787. He directly raised the question to the media: could a hostile organization have interfered with the electronic control system, disabled the engines, and caused the aircraft to crash just seconds after takeoff? Notably, the Boeing 787 series features highly integrated electronic flight control systems, fly-by-wire, relying heavily on processors and digital communication protocols. This makes it a strategic vulnerability if accessed by hackers via ground communication lines, maintenance systems, or even internal onboard devices. A cybersecurity expert once warned, once you gain access to the flight control system through the network, it only takes seconds to turn a modern aircraft into a free-falling metal wreck. This theory not only raises concerns about technical security gaps within the aviation sector, but also sounds a chilling alarm that a cyber war may already be underway, unfolding in silence. The question now is no longer whether we can find the cause, but whether someone truly wanted this tragedy to happen. And if it was indeed a deliberate act, then who stands to gain the most from this globally shocking aviation incident? The AI-171 disaster is not merely a horrific accident. It is a resounding wake-up call to the entire world about the fragility of modern aviation. And in response to the incident, Boeing has issued some initial statements to the media. So, how did Boeing respond after this tragedy? After several days of silence, Boeing finally issued an official statement regarding the catastrophic crash of Flight AI-171, which claimed over 260 lives. CEO Kelly Ortberg expressed deep condolences to the families of the victims and affirmed that Boeing is fully committed to supporting the investigation. An emergency team of engineers was dispatched to Ahmedabad to coordinate with Indian authorities and work closely with the AAIB Aircraft Accident Investigation Bureau of India, the US FAA, and the NTSB National Transportation Safety Board. Boeing also announced its withdrawal from the 2025 Paris Air Show, one of the world's most significant aviation events. This move was seen as a gesture of respect for the victims and a decision to concentrate entirely on managing the crisis. The company stated that it is conducting a comprehensive review of all technical data, especially the engine's electronic control system, EEC, which is currently under scrutiny as a potential root cause of the incident. Although Boeing did not disclose specific figures regarding financial compensation, the company confirmed it would stand in support of Air India, both technically and logistically. One highly symbolic gesture was the official retirement of the AI-171 flight number, a tribute to the lives lost in the disaster. However, Boeing's response has faced strong criticism. Many experts argued that the delay in releasing information and the lack of transparency about potential technical flaws fueled public dissatisfaction, especially after internal documents were leaked showing that as early as 2024, electrical short circuits had occurred near the main wiring cluster close to the EEC, but were not reported to the FAA. Many began to question whether Boeing had knowingly concealed a systemic risk to avoid triggering a large-scale recall. The market reacted negatively as well. Boeing's stock dropped more than 7% on the day of the crash and continued to decline following the withdrawal from the Paris Air Show. Meanwhile, aviation regulators in India acted swiftly. All 34 Boeing 787 Dreamliners operating in the country were ordered to undergo immediate supplementary inspections. These inspections focused on takeoff thrust, calibration, hydraulic system, integrity, and fuel line reliability. The key areas now suspected of playing a role in the Ahmedabad tragedy. Other regulatory agencies, including the European Union Aviation Safety Agency, EASA, and the U.S. Federal Aviation Administration, FAA, quickly backed India's cautious approach. Parallel airworthiness directives were issued, and operators were urged to assess the emergency response performance of the EEC system under simulated failure scenarios. What stands out most is the global chain reaction that this crash has triggered. The International Civil Aviation Organization, ICAO, quickly issued a statement announcing a review of the Dreamliner certification standards, with particular focus on material fatigue testing and emergency evacuation procedures. Airlines around the world were ordered to re-inspect their entire 787 fleets, covering everything from hydraulic systems and fuel lines to composite joint structures. The AI-171 crash is no longer a domestic issue for India. It has become a resounding alarm for the entire global aviation industry. And as regulators begin to reassess every line of safety protocols once considered untouchable, we are forced to confront a question that cannot be ignored. After all the losses, have aircraft manufacturers truly learned anything? A bitter lesson and a reform that can no longer wait. It is time to confront the truth directly. What truly caused AI-171 to crash just seconds after takeoff? Was it merely an isolated technical malfunction or the inevitable result of blind trust in a technology everyone assumed was invincible? The AI-171 tragedy did not only take 269 lives, it also exposed deadly gaps within modern aviation, where every mouse click, every line of code, and every maintenance decision can become the thin line between life and death. Why did a state-of-the-art Boeing 787 crash just 36 seconds after takeoff? Why did both engines lose thrust simultaneously without triggering any prior warning? And why, despite thousands of logged flight hours, were the pilots unable to save the aircraft? The answer does not lie with one individual. It lies deep within the system itself. From flaws in design and software to operational stress and delayed regulatory responses, all contributed to a breakdown of pilot trust in the very systems they relied on. These issues raise fundamental questions about aviation safety and demand urgent reform that can no longer be postponed. And then, what comes next? After the tears that hadn't yet dried the gray ashes still covering the dormitory rooftop and the smoke that continued to rise from charred brick walls, the aviation industry was forced to face the truth. Entire safety protocols were rewritten from scratch. Pilot training programs were put under direct review. New research into composite materials, electronic systems, and emergency simulations began to receive unprecedented investment. The public has changed as well. Passengers today are no longer convinced by polished slogans about the world's safest aircraft. They want to know what really happens behind the cockpit door. They demand transparency, they seek truth, and most importantly, they want to survive every flight. AI 1-21 stands as a chilling reminder. A single system error can cost hundreds of lives in a matter of seconds. And if we fail to learn from this pain, then inevitably another disaster will follow.